When it comes to the interfaces, collection is one interface. Collection is one interface here. I'm just representing with I. So when it comes to collection as the interface, then there must be some implemented classes. Yes or no? Yes. Which class will implement this collection? Those who knows. So for this collection, there is no direct class to implement. No class will implement collection interface directly. No class will implement collection interface directly. So when this collection is not implemented by any of the classes directly, then what is the next thing which is guaranteed? This might have some sub collection, sub interfaces or child interfaces. So in that way, so in this list of interfaces, one of such child interfaces is nothing but there is set. Set is one interface. For this set interface, there is one more child interface, sorted set, and then navigable set. These are the interfaces. When it comes to collection, collection doesn't have any class which will implement it directly. Therefore, it has child interfaces. So one of such child interfaces is nothing but set interface. So again, this set interface has two more childs, that is sorted set and also navigable set. The next collection, which is a child of this collection interface, is nothing but list. List is the next interface under the child of this collection. There is one more interface as the child of this collection called queue. Then other than these, because of some external reason, which we will discuss later, there is one more interface called as map. Map is not a child interface of collection. Map is not a child interface of collection, but most of the Java people also will consider that this map is a child interface of the collection. No, because of some fundamental reasons, map is not a child of collection. I'm mentioning that. Map interface is not child interface of collection. Not child interface of collection. Then this map has two more child interfaces. One of such is sorted map. And then navigable map. How many interfaces are there? Please count. These are the 9 interfaces which we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the 9 key interfaces or 9 main interfaces which we have in collections. So these are just interface only. Then for every interface, there must be some or the other implemented classes as well. Correct or not? Yeah, because only interfaces will not have the implementation of those things. Then to implement all these interfaces related things, then there are the corresponding classes as well. So when it comes to classes, I'm going to list out which we are going to discuss as a part of our course. The remaining I'm not going to list out here because these are the more important parts which we are going to discuss. So under set, there are 2 implemented classes. Any idea? hash set, and then linked hash set. Under list, there is one implemented class called array list. Array list, and then one more linked list. When it comes to map, so there are here hash map. Next, one more linked hash map. Linked hash map. So these are the implemented classes. So again, for your information, there is one point because I'm using the same color combination for all these classes which I have written in green in color. All these classes will accept both homogeneous and also heterogeneous elements. All these hash set, linked hash set, array list, linked list, hash map, linked hash map, all these will accept the homogeneous and heterogeneous elements. I'm using the color combination. I'm not writing the complete details. In this entire collection interface or collection framework, there are two more classes which will not implement both homogeneous and heterogeneous. It will implement only homogeneous kind of elements. That is nothing but the child interface of the sorted interface. That is class of which will implement the sorted called anybody? Tree set. Tree set is a class, and the class which will implement this navigable map and also sorted map is nothing but tree map. So again, I'm using the same color combination. These two, tree set and tree map, will accept only homogeneous elements or homogeneous objects. When it comes to the next point, in this head interface, that is nothing but collection interface, some of the methods which are defined in this collection interface, all those methods which will be supporting each and every sub interface and also the corresponding implemented classes. Because as a parent collection, if it has something, then through inheritance, all those things will belongs to the child interfaces as well as the implemented classes as well. Correct or not? When a class implements a collection, that does the collection methods belongs to class or not? That's where the class responsibility comes, where class has to implement the body for all the methods, right? So these everything is predefined only. All these methods are pre-implemented. Only we have to use them. But there are some methods which are defined in collection interface, which will be applicable to all the child interface and also the corresponding implemented classes. And when it comes to child interface as a set has its own methods. Okay, set has its own methods because its purpose is different. And list has its own predefined methods because its purpose is different. That's where we go for. Sometimes we use the set concept and sometimes we use a list concept. And this map also has its own predefined methods. And here, because this is not a child interface of collection, these methods which are present in this collection will not be applicable to map. Map has its own set of methods which is defined in this map interface as a overall. Then as a child, this sorted map and also navigable map have some methods which will be implemented by this tree map class. Yeah. So this is a point just to remember. Some methods which are coming from collection interface and to each and every classes like hash set class, linked hash set, array list, linked list, tree set, all these things. And some methods which are present in set interface belongs to each and every class or only this implemented classes. Only this hash set class and linked asset class and tree set class. The methods which belongs to set interface belongs to only these three classes or will be applicable to these three classes. When it comes to collection, The implemented methods in collection or the methods which are there in collection interface belongs to all these implemented classes as well. And when it comes to list, belongs to only array list and also linked list. When it comes to map, those methods belongs to hash map and linked hash map only. So here is one more clarity. Am I clear, guys? So when it comes to the next part and the last point before we go for individual details, there is a concept called as legacy class. There are some classes which are called as legacy classes. Only the definition. Generally, what is the meaning of legacy when it comes to any industry? We call Sachin Tendulkar is a legend batsman or legacy batsman. Yeah, or we call Don Bradman is a legacy batsman. We call it as a Amitabh Bachchan is a legacy actor. So what is the meaning of that? So they are there as when the industry has born or when that field has born. Like when it comes to Don Bradman, so he's a father of cricketer, which we call him, right? Because he is the one who has achieved so many things in cricket where other players couldn't achieve even till yet. So that is where he is something called as legend or legacy. So that's in the same way when it comes to legacy classes in Java. So when it comes to the versions of Java, first version is Java 1.0, then 1.2, 1.4, 5, 6, 7 and all. The classes which are there from the starting, that is from the first version of Java, and still we are using them. So such type of class are called as legacy classes. The classes which are there from some other classes were there, and because of there is no further use, they didn't continue in the next versions. But there are some classes which are there from Java 1.0 version to till today. So that's where we call such classes as legacy classes. The classes which are there from Java 1.0 version. So we call them as legacy classes. Any example? Vector is something like it's a class. This is a legacy class. Still we use them. Vector something stack and it's DQ. These are some classes which are there from Java 1.0 version even till today. So we call them as a legacy classes. This is just a definition you can remember. And example, if interviewer asks, you can just say that vector and stack and some more. Yeah. Comes to the next. What is that collection interface methods, which are useful for most and each and every sub interface and also the implemented classes. So we'll discuss them. What are the possible methods when it comes to a collection? What is the definition of a collection? Collection is a container which can be consisting of objects, right? Say for example, if I take student objects only, student 1 object, student 2 object and student 3 object like this. So this can contain some n number of objects. So if it is a collection, if this is called as a collection, then what are the possible things? If at all I want to add one more object to this collection. So there is a collection, maybe empty or with some collection objects. So if at all we want to add one more collection object to this one, yeah, then we have a method called as add method. We have a method called add method. The appropriate syntax. I'm just listing only method names. We'll go for syntax and how to use them in our programming part. So there is a method called add method, which we can add a collection object into this collection. Then there is one more possible method for the second reason. There is one more collection, a child collection or sub collection, you can say. One more collection which has some elements called as some objects like S10, S20, S30, some S40. One more collection which has some more objects. So instead of adding each and every object, adding only S10 once, then S20 once, it is a time taking process, and at the same time, the code will become more lengthy. then can we add this entire collection to other collection? Yes, there is a method. Again, this add only, but the syntax will be different. This is to add individual object. One method to add individual objects. One more method add only, but with the syntax of different one, that is nothing but group of objects, or simply can I say to add one more collection. We can add one object or we can add collection of and some more objects. So these are the add methods only. Here we can go for some directly object and here collection. That's the difference. Next, after usage or after coming to know this, some objects are not required. Some objects are not required to implement the collection methods. Then can we remove this? Yes. Can we delete? Yes. So for deleting, there is a method called as remove. Remove is a method which we can remove one object. Remove is a method which can remove one individual object. Say for example, I want to remove S10, then we can use this remove method by giving the object name. So that will remove S10 from the existing collection. So add two types and remove to remove one element. There is one more remove method. Can we remove one collection? For example, this collection is consisting of one more collection, say 2. In this, there is collection 2 elements are there. Then I don't want these collection 2 elements from this entire bigger collection 1 list. Then can we remove this group of objects? Yes, we can remove. So for that also, again method name remove only. Remove, but again a collection, a sub collection, let me write. If collection 1 is a bigger entity or bigger container, in that there is a one more collection name called collection 2. So where we can add the collection by using add method and we can remove that collection by using a remove method. With appropriate syntax, we will discuss all this with an example. Next, I don't want any elements. We don't want any elements in this collection. Then what's the next expected method? Reset. So there is a method called as clear. Clear method will make the collection empty. This clear method will make the entire collection empty, means nothing will present there. So there is one more method, retain all. Retain all is a method. This will remove every other collection except a specific collection. Except a specific. Just to make you understand. So for example, in this batch, there is some July 3rd batch students are there, July 10th batch students are there, then June 12th and June 19th. So then if at all I want to consider only July 10th, then I want to retain that July 10th students here by removing the remaining all students. In that example, so we can use a method called as retain all method. Means I am retaining all July 10th batch students here by removing the remaining batch students. Okay. So here, what's the meaning of this remove? So this example of this first remove is nothing but I can remove one particular student. Yeah, if I take student is one object, then I can remove any individual. That's the purpose of this remove one object. Then there is remove method. So this will remove a sub collection. Means if I can say, so I want to remove the June 12 batch. It is some sub collection of this entire collection, so that we can use this remove method to remove a particular collection. Then clear. If at all I don't want any students here, in that situation we go for a clear. So therefore the entire collection data will be empty. Our collection will become empty there. And retain all means a particular collection of elements to be there and remaining else should be removed from that collection. So in that situation, we go for a retain all method. Next, once this is clear, once the collection is clear, can we check that is the collection is empty or not? Yes, we can check that. So there is one more method called as is empty with a collection object variable name. If we can implement this is empty method, so therefore this will give the result of the collection is empty or not empty, true or false kind of thing. So here once some elements were added, then can we check the size of the collection? Yes, there is a method called as size. So these are some most commonly used methods, and this support is required for every collection. Therefore, all these methods, maybe some more extra, but so these are the most commonly used. These are present in the collection interface methods. The next part, when it comes to set as a interface, when it comes to list as a interface, and then I don't compare, but just for our understanding, I'm writing map also here. So when it comes to a collection, there are multiple requirements. So what is the requirement is, I want a collection of elements where duplicates are not allowed. A collection of elements where duplicates should not be allowed. And some more situation where collection of elements where duplicates should be allowed. Duplicate should not be allowed is one situation, and a duplicate should not be allowed is the another situation. And there is one more requirement, collection where duplicates are allowed, but no need of the order in which we are entering the values. And there is same situation where order doesn't matter, but duplicate should be allowed. So these are some crisscross possibilities are there. And in that situation, we go for set. Set is a collection which allows duplicates or doesn't allow. Set is the interface which doesn't allow duplicates. Then list is one interface which allows duplicates. Which allows duplicates. Next, when it comes to set, order is random, or the set will store the elements in the random order of elements. Let me write in that way. Here the random order of objects. In set interface, the objects will be stored in some random order. So we cannot say that this is at first position, this is at second position. We cannot say that. It's not possible to access them back in the same way. When it comes to list, it is a ordered collection. Set is random order, or we can say technically unordered collection. When it comes to list, it's a ordered collection. Just one or two points about this map as well. So as I said, map is not a child interface of the collection. So this is a separate interface because the purpose is different. That is nothing but map can store the elements in the order of pair. Map stores objects as a pair of values. As a pair of values. So where we can store the individual elements by using this set, and we can store individual elements by using a list, but we cannot store individual elements by using a map. It's always there's a pair of values. What is that pair, and how do we use the syntax and all? So for all these things, we'll start from set in tomorrow's class. So with this, I'll stop for the day.